The first one is is talking about arcs, angles, and chords. Okay, so very simple. Many of you know about this one. Say what this topic talk about here. So equal arcs. So this is an arc. Okay, so equal arcs makes the same angle in the center. Okay, if arc the same, then center angle should be same. Same thing, if same angle, you can say the lengths of the chords are also equal, so they're all related. Okay, so it's quite simple. Yeah? I don't believe anyone have any difficulty in understanding this concept. It's very, very primitive. Okay, so let's do some practice by the use of this one. Okay, question one. Question one. So what do you do? Okay, in this diagram, prove angle AOC, say angle AOC, this one, and angle AOD. We're going to show these two angles the same. The condition given for this question is arc BC, okay, and arc BD are equal. Okay, in taking this chance, not all of the questions in circle geometry are giving the diagram. So say 80% or 90%, yeah, are giving the diagram for you to follow, but some of the questions are just describing the question. So in that case, you must be able to draw the diagram by yourself. Okay, so read and understand, make a diagram by the use of your hands. Okay, so make sure not every question has this sort of kind and friendly diagram. Okay, but this one, luckily, we have a diagram. Now, I'm going to give you a big picture, okay, about this question, how you move on, okay, how you reach the conclusion. So what I like to say here, say these two angles are same. What's the reason? Because same arc make same angle in the center, okay, which is what we just discovered, okay, what is just covered, okay. And these two the same, and then also the AB is a straight angle which is 180 degrees. Okay, so therefore, this particular angle can be calculated or can be obtained by taking this particular angle from 180. Okay, similarly, we can get this angle by taking this particular angle from 180. So these two angles are the same, so we take two same angles from same angle, but they're placed in different place. But we take we take same angle from 180. Therefore, the remaining angle must be equal. Okay, so that's what I like to do. Okay, let's start. Okay, so what I like to do is to show you how to write your answer properly. So always, okay, not 100%, but more than 95% of your writing must be followed by the good reason with the bracket. Okay, that's the prerequisite of this topic. Okay, let's go on. The first one is, say, COB, so angle COB. What is COB? COB, this angle, and then DOB are equal. Why? Then you need to write something within the bracket. So that's the reason to support this fact. Okay, so that's the given condition. So CB and arc BD equal, therefore these two angles in the center must be equal. Okay, that's the first step, as I spoken to you earlier. And the second one, angle AOC, which is angle AOC. So this angle can be obtained by subtracting this angle out of 180. You get that? So that's what I like to do. How do you know? The reason is that is a straight angle, which is 180. The other one should be the same. Okay, so angle AOD. So angle AOD is obtained by taking the angle DOB out of 180. Then you'll get this angle. Okay. Then what you're going to do is angle DOB is equal to angle COB, as we declared at the first step of this question. Therefore, 180 minus angle COB, 180 degrees minus angle COB, they must be equal. Therefore, angle AOC and angle AOD must be equal. Okay, so that's the conclusion of the question. Okay, it's a quite simple question. So as you can see here, you must provide proper reasoning per steps. Okay, that's the important thing. You understand, guys? Okay, so good feeling about the first question? For sure. Right, so that's the very first question. So let's move on to the next one. Question 2. Okay, look at this one. Prove that BC and AD are parallel. So what is BC? So BC, so this is BC, and AD are parallel. So we're going to prove these two these two lines are parallel. So what's the condition given? Well, AB is equal to CD. Okay, so AB is equal to CD. So we need to use these two are equal. Then you need to reach the point to these two lines are parallel. How we're going to do? It's quite simple. Righto. Okay, we have these chords are same. Then angle in the center must be equal. You get me? The same length. So subtended, the angle subtended to the center from the same chord must be equal. So let's say they are x plus x. Okay. Now, angle AOD is 180, which is straight angle. So you can get this angle by 180 minus 2x. Do you get me? So 180 minus x and x, which means 180 minus 2x. Okay. Now, have a look at the triangle BOC. What do you think about here? So BO is the radius of the circle, and also CO is the radius. So you can say equal radii. All right? These two are equal and equal. Therefore, what do you want to say? The base angle of the isosceles triangle must be equal. So these two angles must be equal. Okay? Now, we discovered this angle is 180 minus 2x. Okay? So therefore, these two base angles must be sum of 2x. So you can say these two must be x and x. Can you see that? Okay? So this is 180 minus 2. So angle sum of triangle is 180, and this says 180 minus 2x. Therefore, two base angles should be sum of 2x, but these two base angles of the isosceles triangle must be equal, so they must be equal x and x. Can you see that? So what do you see now? In here, these two angles the same, guys. Make sense? So in here, what I like to say, if you have here, so these two angles the same, then these two lines must be parallel. So what's the reason? They are alternate angles. Therefore, alternate angles the same, then these two lines must be parallel. So this is what I like to do. Make sense, guys? Okay, so let's go through the questions more formally in writing. Okay, follow this one. So you guys have something to write in handy. Let's start. Okay, first one, angle OAB, sorry, AOB, COD. AOB is same as angle COD. COD here. What's the reason? AB is equal to CD. Okay, so chord AB is equal to CD. That's the given condition by the question. Okay, so therefore, angle subtended to the center from the same chord must be equal. All right. What was the next one? Next one, yeah, if this is x, this must be x. Okay, then we need to find the angle BOC. Angle BOC. Okay, so BOC is 180 minus 2x because it's a straight angle, straight line. Fair enough. Okay. So next one, OB is equal to OC. So OB is equal to OC. So this triangle BOC is an isosceles triangle, as I've spoken to you. Okay. So therefore, the angle base angles of the isosceles triangle must be equal. Okay. So that's 180 minus 2x. So these two angles must be equal. So they must be in x and x, but I'm going to show you how to tell properly they are all x. So here, in this triangle, triangle BOC, angle sum of triangle must be 180 degrees, right? So OBC, that plus that, which is OBC plus OCB, because this plus this is, and add 180 minus 2x. So angle sum of all three angles in the triangle must be 180 and 180 degrees, sorry, okay? Then that plus that is 2x because we can cancel 180 and 180, move 2x to the right hand side. And then we know these two angles the same, okay? So therefore, this is x, therefore, OBC, so they are x and x. Therefore, what this is saying, these two angles are same in x, okay? So we can say they are parallel because they are alternate angles, okay? So that's how you move on. Easy. So whenever you start, whenever you handle this sort of question, please think about the big picture first, rather than just writing all the time. Think about it. Okay, you must have a big picture first. How I am going to cover. Okay, how I am going to write the whole thing properly. Okay, that's quite important. Don't stick into the question straight away. Okay, have a think, then write. Question 3. Prove. Okay, AF and BG. Okay, we're going to prove these two sides are equal. So what's the perception of this question is assuming these two circles are sharing one common center. So what, hey guys, what do they call these sort of two angles? What do they call this one? Remember? Yes? Yeah? Eccentric or concentric, okay? So it's the same angle, it's the same center, sharing the same center, we can say concentric circles, okay? Now, how are we going to do now? Okay, try to use the congruency or most similarity. Similarity is not being used, mostly congruency. Okay, I'll show you this way. So look at this one. We just construct something here. Okay, so OF, OG, what do you think? Yes, they are equal. What's the reason? Because same radii in the same circle, so they must be equal in length. Okay, open your eyes to see the big circle. So what do you want to say? You're going to say big circle over there. Are they equal? Yes. Okay, so still the same radii. Okay, so it's working the big circle. So these two radii must be equal. Okay, almost there. Now, what else you need to do? Okay, look at the big triangle again, which is AOB, which is the AOB like this one. AOB here. What is it? Yes, that's an isosceles triangle. Okay, because same radii. Right? Therefore, these two base angles must be equal. Now, what you can see, have a look at the triangles OAF and OBG. Do you think they are congruent? Do you? Okay, they are, because two sides are equal in the triangle, and the other two sides are equal. Yes, and then one of the corresponding angles are equal. So therefore, congruent triangle, which is exactly the same. Therefore, these two triangles are congruent. The corresponding side must be equal. So that's how we're going to show. Make sense, guys? So once you feel okay, then start writing. Okay, I'll show you how to write this one. Okay, what's the first step that you want to write, guys? Is OA is OB, which is OA is equal to OB, so equal radii, same radii in the big circle. What's next? Same thing. OF is equal to OG, same equal radii. Okay, within the smaller circle. And then what else? Do you remember that, guys? Angle OAB is equal to angle OBA here. So these two angles are the same because big triangle is an isosceles triangle. Therefore, two base angles are equal. Make sense? So what do you want to say? So you can say triangle OAF, okay, and OBG are congruent because this the same. Okay, the longer sides are same in length in pair, and the shorter side also same in pair, and then one of the angles are equal. So therefore, angle side. Okay. Sorry, it should be SSA or SAS. That's not correct. Okay. So side AS. Now, what are you going to do now? Therefore, the corresponding side must be equal. That's how you write it. Understand it? It's quite simple. Okay. It's very simple, but took a long time, took a little time to consider in writing. Okay, question 4. Okay, in question 4 saying, okay, prove CM bisect PMQ. So CM bisect the angle PMQ here. So we're going to prove these two angles are equal. So what do we need to use? The arc MQ is equal to this arc. It should be quite easy. So we know these two arcs are equal, so therefore the corresponding center angle must be equal. You get me? And then what else? PC and CQ are equal. What's the reason? Equal radii, right? So, and then what else? You can see CM. CM is common. So what I did, guys, in triangle PCM and triangle QCM, these two sides are equal. This is common for two triangles, and the center angles are equal. Okay? So therefore, two triangles are congruent. They're exactly the same. Therefore, the corresponding angles must be equal, which means CM bisect the angle PMQ. That's what I like to do. Make sense? Okay, we'll try to move on in writing properly. Okay, you guys ready? Ready in writing? First one, MCP. Okay, angle MCP is equals to MCQ. Two angles the same. Reason? Okay, equal angles at the center stand on the equal arc. Okay, so equal angles coming from same arc. Okay, which is what I discussed with you guys earlier. And next one, CPCQ. CPCQ, yes, equal radii, right? What else then? Yeah, CM. Okay, CM is common for those two triangles. Yeah, so same those triangles. Okay, so guys, we are talking about the triangles PCM and QCM. Okay, so we just proved those two triangles are equal, right? So sorry, congruent. Okay, then the corresponding angles must be equal. Okay, the corresponding angle must be equal. So therefore, CM bisects these angles exactly in half. So you can say CM bisected. Okay, so easy. So once you understand the basic principle and basic strategy, it shouldn't be a big trouble. Okay, question 5. Prove that AB bisects angle MAN. Okay, so this AB bisects angle MAN. So we want to prove these two angles are equal in these two circles. So what you have to do here, the first step, okay, I'm going to also give you a big picture first. The first step is to show, to mention these two sides are equal because equal radii. And then these two sides are also equal because equal radii in the same circle. Okay? And then the side AB is also common. Okay? It's common. So therefore, the triangle A and B and triangle A and B are congruent. Can you see this, guys? Therefore, these two angles are equal because corresponding angles of two congruent triangles. Make sense? So that's what I like to do. Okay, let's get started, guys. The first step is to show AM equals to AN. Okay, so AM is equals to AN. So equal radii. Next one, yes, same thing. BM is equals to BN. So same, equal radii to the circle in the right hand side. Then AB is common. So AB is common. So SSS. Okay. So the triangle A and B is congruent to A and B. Okay. Therefore, angle A and B and NAB the same. Okay, so these two angles the same. So therefore, AB bisects angle MAN. So easy. Okay, it's quite easy. Okay, so we just proved the first part. Let's move on to the next one. So the next question is asking us to prove AB bisects MN. Okay, so AB bisects the segment MN and intersect by right angle, okay, 90 degrees. So what I like to do, the first thing is this one. In these two triangles, okay, so I'm going to start again. We proved these two angles the same from part A. And then, again, AM is equal to AM, okay? And then the AP is common. So therefore, these two triangles are congruent here. Get me? Therefore, two corresponding sides, corresponding angles are equal, but sum of two corresponding angles are is in 180 straight angle. Therefore, there should be 90-90. So it's an at right angle. And then these two sides, the MP and NP, are equal because they are corresponding side of the congruent triangle. So therefore, they're cut in half. Okay, so that answers the question. Make sense? So let's do the question now. Okay, first step is to AM is equals to AN. Okay, make sense? Equal radii, same thing. And the next one equals to MAB, okay, and NAB, okay, NAB. So these two angles are equal because we already proved. Next one is AP is common here. So AP is common. Therefore, the triangle AMP, AMP, and ANP are congruent. Easy, okay, it's quite easy. Now we can say, okay, then therefore the angle APM, this one, and APN are equal because they are corresponding angles of congruent triangles, okay? But these angles are in a straight line, so therefore there must be 180 together, but they are equal, they should be 90-90. That's what I said today. And then next one equals to, so side MP and PN are equal because they are corresponding side of the congruent triangle. Therefore, conclusion. Okay? So, yeah, basically this is one big question, but some question may be separated into two small sections, but overall it's just one question. Okay? So that was question 5. Question 6. Question 6. Prove that AB is equal to AC. Okay, we're going to prove these two sides are equal. Basically, we may be able to prove this big triangle is an isosceles triangle. Right? Now, the condition given is this one. Arc BD is equal to arc CE. Okay, so we need to use this one. How do you do? Well, what I suggest you to do, make some construction over there. Make some construction over here, okay? Then, what do you want to see? Well, your first step is this one. Due to the fact they are same arc, produce same center angle. So these two angles are equal because it's produced from the same arc, okay? And then, these all four sides are equal because radii, okay? Radii in the same circle. Then, and what about here? What about this triangle? So OBC triangle is also isosceles triangle. Reason is they are equal radii. Okay, so therefore these two base angles are equal. Okay, make sense? Well, come on here. These two triangles are also isosceles triangle. So you can say that they are all the same. You get me? Therefore, this plus this should be same as this plus this. So angle B should be equal to angle C. Therefore, this big triangle is the isosceles triangle. Therefore, you can say, two corresponding sides are equal in isosceles triangle. Okay, so there's a big picture. So can you remember that? Okay, now I want you to start writing the solution while I'm erasing the board. Okay, then please follow me. Did you guys start in writing? Okay, I'll show you the first step. Angle DOB is equals to EOC. EOC here. Okay, they are equals. This is reason. Equal arcs subtend, equal angles at the center. Okay, next one. All four sides are equal. Okay, because equal radii in the same circle. And next one, so therefore the triangle DOB is equals to EOC. So they are congruent. So what are you going to say? DBO, okay, DBO, this angle is same as ECO. ECO, these two angles are the same. And the bottom one, angle OBC, is equal to OCB here, because base angles of the isosceles triangle. So triangle OBC is an isosceles triangle. So the two base angles must be equal. Therefore, this plus this must be equal to this plus this. This is what it tells, right? And then finally, therefore, the angle B is equal to angle C. Okay? Therefore, we can say, oh, we just proved big triangle ABC is an isosceles triangle. Okay? Therefore, two sides are equal because the side of an isosceles triangle. Okay? Okay, guys. What we discovered throughout this lesson is basically center angle. Okay, should be subtended to the same arc, must be equal. No matter how many arcs you have, all center angles subtended from the same arc or same chord must are to be equal. Okay. Inversely, if you have the same center angles, then subtended to the circumference, the angle or the arc or the chord must be equal. Okay. So that's what I did just covered. Okay. So we'll see you at the next lesson, guys.